Linear equations are the simplest type of equations to solve. You just get x by itself. Many problems do not fit this paradigm, however. The first type of nonlinear equations that we can look at are the absolute value equations. And for the absolute value of x equal to 1, we're asking what values are 1 unit away from 0. And there has to be two answers from this. So the absolute value of x equals 1 gives us two answers, x equal to 1 and x equal to negative 1. This is kind of how we can solve absolute value equations that are linear in nature. We can get the absolute value by itself and split it up into two equations. So for this first one, I'm going to solve this by adding 2 to the other side. 1/4 the absolute value of x equals 7, and then I'm going to multiply by 4. That gives me the absolute value of x by itself. 7 times 4 is 28. At this point, I can break this equation into two equations. The first equation is going to be the exact same thing without absolute values, so x equals 28. And then we're going to drop the absolute value for the second one, equaling the negative of whatever's on this side. So there could be a lot of things on here. Here's only one thing. But if there's a lot of things, you're going to make negative everything or flip the sign of everything. So these are the two solutions. There's nothing else to solve here. X is by itself. So x equal to 28 and x equal to negative 28 are the answers. Okay, for this problem, once again, get the absolute value by itself. Let's subtract the 6.7. That's going to give me the absolute value of 3x minus 2.4 equals, subtracting 6.7 from this, that's going to be 1615.3. And at this point now I can break the equation up into two equations. The first one's going to be the exact same thing, but without the absolute value. And the next one's going to be the same thing without the absolute value, but now we're going to make negative the other side of the equation. So we're going to make this negative. Okay, and now these are both linear equations. We can solve them by getting x by itself. That's going to give us 17.7 divided by 3. And that'll give us, use my calculator here, 5.9. Okay, the next, we're going to do the exact same process. It's the same equation. We're going to add 2.4. Negative 12.9. Then divide by 3. Giving us negative 4.3. So here we have two different solutions that we had to find after we did this extra step, but we get two answers for this one as well. Okay, now when you're solving these equations, you can think of them as a system of equations. There's two equation sets here. There's the absolute value and whatever's on that side. In this case, it's a constant function, just 22. The same thing is true for this first one. We have the absolute value equation and then a constant one of 5. And we can think of it as a system of equations, and we can graph it as such. So for the first two equations, we had this is the left-hand side, and then y equal to 5. 5 was what this was equal to. I'm just going to graph it like this. And now I want to look for the point of intersection. That's how you solve the systems. And as you can see, we have one here at negative 28. 5 is what y equal to. That was the constant 5. And positive 28. That was the exact answer we found here. Positive 28 and negative 28. Looking at this one, this is going to be the first equation, and the second one's going to be y equal to 22. Here's the first equation, and y equal to 22. Okay, in the system, we're going to solve it by looking at the point of intersection. That's going to be at negative 4.3 and 5.9. 5.9 and negative 4.3. So we get the same answer. The 22 is what y equals. That's the constant function here. This can have an x on this side, however. It could be like 22 minus x. And then you're going to end up getting some kind of linear equation here, 22 minus x. And then you just look for the point of intersection there. In this case, it would be negative 6.45 and 4.425. We're looking for x because x is the variable in each one of these. Well, it's the only variable here. The y is just created from when we make y equal to the other side of the equation. So 22 or 5. Now, absolute value is a distance, and distances are never negative. Keep this in mind. So the absolute value, for this one, we divide by 2. The absolute value of 2x minus 5 equals negative 3/2. This has no solution. Because we're saying a distance is negative 3/2. No, that's not possible. Whenever you have it equal to negative, you can stop there. No solution is the answer. If you were to actually test this on the graph, let's go ahead and test this real quick. Okay, here we have the first portion. This is the left-hand side, and then we have this was equal to negative 3. And you can see there's no overlap here. There's no solution. There's no point of intersection. It's kind of like as if it were two parallel lines, but in this case, they're not parallel lines. There's just no overlap, so no solution. Of course, a distance can equal 0, however, so let's divide by 0. The absolute value of 2x minus 5 equals 0. And there's no reason to break this up into two equations. 0 is neither negative nor positive, so when you multiply it by a negative or positive, it just goes away. So this really just becomes 2x minus 5 equals 0. Add 5 and then divide by 2. The answer is x equal to 5/2. There's only one solution whenever the absolute value is equal to 0. Let's graph this one. So this is really the same thing as the previous one, except now we have y equal to 0. I type 0 into there, you're going to see there's only one point of overlap right here at 2.5, which is what we found. Give it a try in number 1.